During some of the final commissioning in Dallas, I found myself sitting on top of an empty pallet as it traversed through the palletizing system. Now, mind you, these pallets were only maybe a foot and a half off the ground, so it's not like I was doing anything particularly dangerous, but I needed to do testing on a system that really wasn't designed for empty pallets, so I needed a way to actually test the logic. It wasn't particularly easy to get to the pallet conveyor, so trying to build a pallet and put cases on it so that they were high enough to trigger the photo eyes just really wasn't an option. So here I am throwing a pallet onto the conveyor, getting on that pallet, and letting logic send that pallet down the line. And all I'm doing is making sure that when I pass a photo eye, I'm flagging it. Once the pallet gets to the end of the line, I get off the pallet, pull the pallet off the conveyor, and do it all over again. That moment is kind of a perfect summary of what Dallas was. Not glamorous, not elegant, just doing whatever it takes to make the system work correctly. Welcome to From the Bucket, where controls design meets reality. I'm your host, Keely Smith. In this podcast, we explore industrial control systems as they exist in the field, not just how they were designed in CAD or how they look on paper, but how they operated in a production environment, how operators and maintenance interfaced with them, and the fun and interesting stories that I've made throughout the years of being a controls engineer. If you've been listening to this podcast from the beginning, you've heard a lot of stories about my time in Dallas. You've heard a lot about what the place was to me. From the systems that we've built before, but not really having any direction or documentation to go with it, to what the road life was like, the 16-hour days, the 3-4 weeks on and the couple days off, and the mental load that really you could never turn off even when you were not on site. You heard the episode about chasing perfection on a line with math and spreadsheets, and the eventual realization that industrial systems don't really care about how clean and good your math is. You heard about the temporary line that we built with a bunch of refurbished equipment, but it was never really all that temporary. The fire alarms, the operators having to clean up. And now we're kind of at this episode, which, at least for my story, this is kind of it for Dallas. The last real integration that I did here. Because up until this point, we've really focused a lot on what the lines looked like, but we've only briefly touched on the overhead system, which was actually quite extensive, and it was quite a big part of the completion of this project. So to really understand this part of the project, you have to understand the physical layout of this facility. So again, as we kind of mentioned in some different episodes, everything wasn't really in one room. So everything was segmented out by your sterility zones. So your filler was pretty much always segmented off into another room. Then you'd actually have your end of line conveyors, accumulation, case packers, all of that fun stuff. And then there was the palletizing area. So in this facility, the palletizing area was one centralized spot in the factory. And even at the closest line, it was probably still 500 to 600 feet of overhead conveyor to get to the palletizing area. For my projects, though, all of the palletizing areas were thousands of feet away from the ends of my lines. And these pieces of conveyor were at least 20 foot in the air. By the time they got to the palletizing area, it was 3 different levels of conveyor. And these really weren't just straight sections of conveyors. They would go around corners in the building. We'd have to avoid different structural members. So these conveyors kind of twisted and turned all the way out to the palletizing area. So the conveyor that we actually used for this was pretty cool conveyor. If you've worked in distribution or material handling, you've probably seen it. So the conveyor it was chain driven, zero pressure accumulation conveyor. So the way it works is that each section of conveyor basically operated as an independent pneumatic zone. So when a zone downstream became clear, a small pneumatic puck would engage, and that would push the chain up against the rollers, and the product would start to move forward. When it wasn't clear, the puck would release and the chain would disengage off of the rollers. So the chain would just sit there and keep spinning underneath, but it wouldn't be driving anything. So it was awesome conveyor. Like the idea was absolutely beautiful. It was zero pressure accumulation, but you didn't have a whole bunch of complex controls. So cases could actually sit there and wait for the next zone to be clear without smashing into each other. So, you didn't have back pressure, you didn't have jams, you didn't crush any of the product. And the cool part is that it was all self-contained per zone. So there really wasn't anything that you had to do with the control side. It was more along the lines of how you pneumatically connected everything. At least that's how it was supposed to work. So this was, like I said, the end of what I needed to integrate at this facility. So I needed to get it from the end of my line to the palletizing. So that meant I needed to figure out how like the photo eyes worked, how this puck system worked. There was some pretty basic logic of how the motor contactors actually drove the motor, and how to kind of wire all this stuff back up into my line controls. So I kind of had a little bit of visibility of what was going on uh, 20 feet over my head where I couldn't even really see it. But the thing is that I'd never touched this conveyor in my entire career. So there was some learning to it. And I think that's probably a really kind way of saying I had no training on this system. It's not like there was a manufacturer's rep just sitting there walking me through it. There was kind of the tribal knowledge that the mechanical install team had, and there was the manual. So I remember spending a lot of time just sitting there kind of watching how the conveyor works, because when it was all set up correctly, it it made a lot of sense, and you could actually kind of see these pucks engaging and disengaging, and you could see the brakes doing what they needed to. So there was a lot to be learned just by watching this system operate. And while normally I'd say, absolutely, I want to control all of this stuff, like I mentioned, each one of these zones had its own zone controller. So I didn't really have to tell it to do anything. It made its own decisions based off of the conditions that it was seeing, of whether it should uh, be accumulating or sending cases down the line. So my whole job was really to understand kind of the interface points and anything that I really needed to do with this. Like where could I talk to this? What information could I pull from it? Uh, what control I needed to have over it, and basically what was completely hands off. And for a while, the answer to most of those questions was, I didn't know. I had to kind of get comfortable with the fact that I didn't know this and understand how this system was supposed to work so I could actually come up with my control scheme for it. But here's the thing, and this is where it got interesting, was on the new sections of overhead that we had installed for the previous projects. Uh, things weren't working right. And when I say it wasn't working right, there was just a few sections where the cases would actually push through the brakes. And the problem with that was when you accumulated on corners with this particular conveyor, there was a possibility for cases to rotate and actually get stuck in the corners. And you basically needed to make sure that there was no possibility of putting these cases into these corners, because trying to clear a jam uh, of cases in the corners 20 foot up in the air kind of sucks. You have to go find the equipment, you have to get up there, and it ends up taking quite a bit of time. Now, I mentioned that one of the things that we really had going for us was a lot of our mechanical install guys had this pretty tribal knowledge of how they wanted to see this overhead run. So one of the things that they did, which I don't actually remember if that was in the manual or not, I don't think it was, but when we activated a brake zone, they would actually drop out the zone that was just upstream of the brake. So you had the brake that was forcing the rollers to stop, and you had the zone directly upstream from it was not actually spinning either. So it gave you a really good braking area. Now, what was actually happening though was we would activate the brake, but the upstream zones weren't releasing. So you'd have all that back pressure building, and eventually the weight of the cases lined up enough behind the brake that it would just start pushing product through that brake. So you'd get the cases piling up in the corner where they weren't supposed to be. And part of the issue with this is it looked like a controls problem. So naturally, with it looking like a controls problem, it must be my problem. So the first assumptions were that I had something set up wrong, which the problem with that is that I have no real programming control over the air brake behavior. So that was all handled at the zone controller level by the pneumatic systems. So there really wasn't something that I could do from the code perspective to fix this. It was actually strictly controlled by how the pneumatics were actually plumbed up together. But no matter how many times I tried to explain this and like show that, hey, there's really nothing I can do here, um, I wasn't getting anywhere. So I eventually just got up in the lift myself and pulled out the manual, and I started going through how the system was actually supposed to be plumbed, which airlines went where, how the solenoids were supposed to be oriented, what the airflow path was supposed to look like. And I started comparing it to what was actually in front of me. And one of the things that I found was it actually wasn't right. So when we looked at how the brakes were working, you could actually see that brake actuating. The problem was is that it wasn't plumbed to the correct air, so there actually wasn't enough air pressure to fully engage that brake and make it so that the brake was really holding the rollers back. So that was one part of the problem that was allowing the cases to push through. It just wasn't actuating enough. The other problem was that the way that the zones were plumbed up was also not quite right. And one of the main things that you see happen with this type of conveyor was if you plumbed the lines up wrong, you wouldn't get the air pressure that you needed, because these were very precisely set up to deliver the right air pressure to the right zones at the right times. So when you start mixing up the different lines, you run the risk of not actually having the air pressure where you need it to be. The other cool thing that I had going for me was there was 5 other lines around the line that I was working on where I could look at how the air was plumbed up for those. So between the manual, and looking at how we had plumbed up the other lines that were working, I found it. I found the problem that we had. So I started pulling off a bunch of the airlines and replumbing it and started doing a bunch of this on the different sections, and it worked. So eventually the mechanical lead came over to see what I had done, and I had shown him, and I was like, look, here's what I did, and this is where things were kind of mixed up, and now it seems to be working. So that was it. Weeks of arguing that it was a controls problem, and it's something that I'm doing. We resolved it by I got up in the lift and I read the manual. So uh, it was one of those really satisfying moments because I think there's a general tendency of when things don't work, the first thing that most people do is say, it's a controls problem. And it was kind of cool that it actually wasn't a controls problem this time. And it was resolved by, the controls engineer getting in the lift and reading the manual. But that was a lesson I carried with me for basically the rest of my career. Just because something looks like it's your problem doesn't necessarily mean that it is. And I'm probably a little biased because I am the controls guy, and it's always nice to be able to go back and say, "Ha, it wasn't actually a controls problem; it was a mechanical problem." But even if it is a mechanical problem, there are times where maybe nobody else is going to figure out, so you kind of have to. And it was a cool moment of kind of learning how the different pneumatics worked because again, all of my training, all my education really didn't prepare me for being able to look and try and diagnose pneumatic systems. So it was that part was pretty cool. So once we were kind of finished with getting the conveyors all running out to the palletizing area, uh, we got to focus on actually a really cool piece of machinery. But first, I'll explain the issue. So when we were running 3-pack containers off of the line that ran 210 cartons per minute, that was actually way too fast for a single palletizer to run. So what we had to do is run the single line to two different palletizers because then the two palletizers could actually keep up. So we had to split the flow, and the piece of equipment that we got was a slat diverter. And if you've never seen one of these run, it's actually a really satisfying piece of conveyor. And the concept's really straightforward. So you basically have a series of slats that are controlled by a rail underneath. So as the belt is running, these slats basically just follow this rail. So if you want to just go straight, you don't do anything. You just let the conveyor run. The slats just continue to run straight. But if you want to divert, you actuate a solenoid, and it actually diverts the track. It's kind of like a train track that instead of it running straight, it actually diverts it. So it's really cool to watch. And what I had to do with that was kind of figure out a rhythm, because the thing is that sure, you could go really simple and every other case you send to every other palletizer, but there's two things wrong with that approach. The big one is that's a huge amount of wear and tear that you really didn't gain anything. So what I essentially did with it was I'd start counting the cases, and I kind of figured out that 5 cases was kind of the perfect amount of actuation to where the machine wasn't just sitting there going back and forth all the time, but with 5 cases, I could keep both of the palletizers pretty well fed. So one of the pieces of the project that was really genuinely fun about this was trying to kind of figure out that rhythm of how many cases is the right amount of cases, because the the thing that I kind of enjoyed about it, and looking back at it now, I kind of understand why my mechanical install lead wasn't super thrilled about what I was doing. Was it was kind of fun. I could basically send one slat here, one slat there, one slat here, and again, it's the machine was designed to do that, but it's just like everything else. The more you stress a machine, the more wear and tear you put on it. But it was just kind of one of those neat things where you could you could have this level of control over something that is generally a pretty straightforward thing with overhead conveyor. So it was a really neat little piece of equipment that I got to program and get set up for this line. So after we get the diverter all set up, we're finally to the palletizing and pallet conveyor side. And so this was kind of a weird one for me because I really came into that part of the project in a different way. So the controls engineer that had done all of the programming on the palletizing slash pallet conveyor side was tied up with another project at this point. So he couldn't really get out to the site to get this stuff all working well enough so that they could start to run through their testing, because there's a big push in getting a production line up and running of just getting the testing moving. So it's not like everything has to be perfect to get the testing running, but you need to be able to basically keep the filler running. So that's what we needed to do. But like I said, he couldn't get out there just yet. So I got about an hour of his time on a phone call and a collection of code blocks where he spent some time explaining, like, this is what this does, this is kind of how this works. And it wasn't really meant to make me a pro at getting all of the palletizing code set up and working right. It was just enough to get it running. And again, this is a really important distinction that I've come to appreciate more the longer I've been doing this, is that, just because a system's running doesn't mean that it's good. So again, I understood what the code was supposed to be doing in like the very broad 50,000 foot view, and I could keep things moving, but there were a lot of edge cases that I didn't really understand, the behaviors that I hadn't really seen, and the logic that, again, I could look at it and understand it well enough, but not really to the point where it's like, oh yeah, I understand how he's diverting pallets from one system to another, because that was one of the really cool things about having the centralized palletizing is we could push pallets that, if they were coming from like the end lines, and say those end lines, the pallet wrapper went down, we could push the pallets from the end lines all the way to the front lines, and we would just basically zipper merge them in, so we could push all that traffic through different pallet wrappers. So it was a really cool concept, but I just didn't understand it well enough to be the one to implement that logic into what I was doing. So my whole goal was I just needed to get it so that I could take a pallet from the palletizers, send it down the line into the wrappers that were dedicated for this. So when he finally made it out to site, the difference was immediate. He sat down, he went through the code, he made the adjustments that I really didn't know how to make, and got it to where it was doing everything that I was supposed to. And it was cool because, watching him kind of work through it was like its own kind of training for me. But it's, there was a time between watching him get everything all set up and working perfectly and trying to get this thing running that, that's where the empty pallets came in. And, this pallet conveyor system was designed around loaded pallets. A full pallet is way different of a profile. It's heavier, it's taller, it's more visible to sensors, all of that fun stuff. Empty pallets they're not. They're low, they're light. Uh, and in a lot of places, the zone sensors would see right over it. So during testing with no product loaded, the system really couldn't see what it was supposed to be seeing. So that was where, I got to sit on the pallets and trigger the photo eyes. Looking back at that now, it was a very specific thought process of, that early career problem solving that it's kind of fun to look back at. And I think that it's some of the stuff that you kind of lose the longer you're in this and the more professional you get of, yeah, probably shouldn't have been riding on pallets, but at the time it just kind of made sense. It's like, all right, well, I can't really get pallets on the conveyor system and put a bunch of cases on it and then pull off the pallet before it gets to the different equipment. So, what, if I sit on the pallet, then once it gets to the spot where I need to pull it off, I can just pull it off. So, it's one of those kind of fun things that you look back at and you're like, yeah, I probably shouldn't do that, but at the time it made sense, and I didn't quite have everything that I needed, so I improvised. I think that there's always some level of humor that it's a lot more humorous when you're looking back at it uh, much later than the time that you experienced it. But one of those moments that I had in Dallas was with an electrician and a motor. And it's kind of one of those stories that, again, I look back at it now and it's like, oh, well, that's really obvious. And I don't know how this turned into what it turned into. But, we had a motor on the overhead system that kept popping fuses every time we tried to run it. And at the time, my electrical knowledge was it was solid enough to know that a motor popping fuses was bad, but it really wasn't solid enough to really be able to get into the nitty gritty of why it was popping. And one of the things that I didn't know, and now I know, is that when you have only a couple of fuses popping on a three-phase system, it's more than likely that you're single phasing that motor. So one of the legs of the three phase isn't making the motor or making it to the motor. So the motor tries to run with the two phases that you've sent it instead of the three. And it ends up drawing way more current than it should and blows the protection. So, like I said, I didn't really understand this at this point in my career. And I just like, I'm looking at it, I'm like, I don't understand this. And the funny, not funny part, I guess, is that the electrician really didn't either. Or, if he did, he wasn't connecting those dots in the moment because his solution was to just keep throwing fuses into it. Which, okay, every time you did that, he'd pop the fuses and then he'd try again. At some point, though, we ran out of the right size fuses. So he starts putting some bigger fuses in there. He's looking at it and saying, well, I got 12 gauge wire here, so I can put up to 20 amp fuses in here. So now he's starting to bump up the fuses to see if it won't pop anymore. So he's doing this for a while, and at some point, one of our mechanical install guys comes running into the room, waving his arms, yelling, "Stop! Stop! Stop! Stop!" And it was because the motor was glowing orange, like it was visibly cherry red and orange. Like I didn't see the part where he was saying, like, there was liquid copper dripping out of the windings. So I can't tell you that actually happened, but he's yelling at the electrician like, yeah, there's liquid copper dropping out of the windings. But so I didn't see that part, but I did see the glowing part, and it was pretty impressive. I don't think again to this day I've seen a motor glowing that cherry red and orange. So obviously that motor was done. Um, and now we kind of had to figure out why. So I started digging through forums, and which to me is kind of funny, talking about digging through the forums now, because this was before you could just ask an AI and get an answer 10 seconds later. So like I'm just going through all these forums, and the more I read, the more this idea of single phasing keeps coming up, and I'm like, oh, okay, so how do I figure out what this single phasing is? So we ended up pulling off the cable duct covers, and there it was. We had two wires going into, or they coming from one conduit, and we had another wire that was coming from another conduit. So the somehow at some point the wires kind of got twisted together when they were getting put into the contactor, and that's how we ended up doing the single phasing. And you could see it, like it was so obvious once you did it. And once we rewired it correctly, put the new motor on it, and hey, guess what, it ran fine. And what I really took away from that wasn't about uh, single phasing. It was really about the danger of solving the wrong problem. Because, every time that motor blew a fuse, the answer really wasn't to keep putting bigger fuses into it. The answer really was, or the question, I guess, really was, why is this blowing fuses in the first place? And, we really didn't stop to ask that question until it was too late to save the motor. But it was it was an interesting lesson to kind of learn and go through this troubleshooting experience, because I again was young enough in my career to where it's like, okay, well, maybe we did just have the wrong size fuses. And really, again, like I said, that was the wrong question. And I still am sitting here many years later, and I think about that question as I'm looking at uh, troubleshooting things of like, okay, wait, when this design was done and this fuse size was selected, there was a reason for that. So if we're popping fuses or blowing overloads, it's not necessarily that things are undersized all the time. It's probably that there's something else going on in the system. So, okay, cool. We got all of the mechanical, the controls, the electrical, all of this stuff is set up, it's running, we're all good. And one of the things with controls is that, controls is typically the last group on every project. Mechanical gets done, electrical gets done, and then the controls group is still finishing up while, everybody else starts moving to the next job, which that ends up meaning that by the time that the project is winding down, the experienced guys are gone, pulled over to like the next sites, other projects where, they needed more of that expertise. And, the job site started getting smaller and smaller every week. And at some point, somebody from the project management team flagged that the forklift protectors hadn't been installed. And these were big steel goalpost structures, like super heavy pipe welded onto frames that prevented the forklifts from running with their mast up so that they wouldn't hit the conveyor structure. It was they were super important because this facility had situations before where uh, like a forklift operator had their mast up and they smacked something. So here we are talking about these forklift protectors and how they needed to all be welded up and everything. And everybody starts looking around, and the most experienced mechanical guy on site looked at me and was like, "Dude, I don't know how to weld." And I remember, like, I looked at him and I laughed and I said, "Well, I used to weld quite a bit." Here's one of the things that, I don't talk about very much, but In high school, I spent a huge amount of time in the shop welding. I loved it. I was actually pretty decent at it, and it's like one of those things that I found early in my life that just clicks, like the process, the focus, the way that you actually can build something out of it. It was really cool, and it just was something that really resonated with me. And then I went to college. I got my engineering degrees. I started my career, and that chapter just kind of closes, right? Because engineers don't weld. That's not typically how it works. You go into this field and you kind of are in this lane, and your lane is really most of the time not got anything to do with fabrication. So all of that would be, kind of the normal flow, except for in Dallas. So after I told the mechanical guy that I know how to weld, I spent the next few days under a hood at this facility welding up these forklift protectors because I was the most experienced welder on site and somebody had to do it. And I'll be honest with you, I didn't mind it at all. There was just something really satisfying about it. This thing that at one point in my life I had really enjoyed and I I really spent a lot of time doing and just kind of had assumed like, that part of my life was behind me was kind of back. I'm doing it again, Same skill, completely different context. And in a way it was so Dallas. You showed up expecting that, this is what you were doing for this trip, and then you end up doing a bunch of different other things that you really never expected. And I think that this is why like it's been so fun talking about these Dallas stories for the last few episodes because when I tell the stories, you start to see the line of where, I showed up in Dallas as a programmer, and that's what I was. That was what my skill set was. I could write the code, I could build these systems on paper, I could think through the logic. That was kind of my skill set. But Dallas was different because it kept putting me into these different situations that I really didn't have any knowledge and training on. It was just something that I had to figure out. I had to figure out mechanical things to the on the line that was temporary because it wasn't going to be the software side of things that fixed it. I had to learn the electrical sides of things because I was there on site and I needed to get this motor to work, and I had to work through figuring out what the single phasing issue was. I had to learn how the pneumatic conveyor systems physically got plumbed and how they worked because I needed to get it done. I spent time on the pallets trying to run through the logic. I just had to figure out what I had to do to make something happen. And, I guess through all of that, I had to weld together some pallet protectors. When I went to Dallas, I was this really young, dumb engineer. And it's so interesting to think about it that way because a couple years later when I left Dallas, I still was a young dumb engineer, but I was really a field engineer at that point. It's not like my title was I'm a field engineer. My title was the same, but in all the ways that actually mattered, I actually could understand the full picture of what it takes to build and commission a production line at this point. Not just the little controls pieces of it, but all of it. And that's really the thing that I gained of 2 years of being at this place. And I can't sit here and say I loved every moment of it when it was happening. There was a lot of days where it genuinely was hard and it genuinely sucked, but I wouldn't trade any of it because everything I've done since Dallas, every project, every line, system, machine, uh, you know, it all started from all this knowledge that I gained from doing all these projects in Dallas for the first couple years of my career. This is From the Bucket, where controls design meets reality. Until next time.